Hey everyone, welcome back. Hope you all are doing well. So, another problem from binary trees. Let's see the problem statement. I'll meanwhile check if I'm live. Yeah, we are. Okay, so let me show you the problem statement for today. So, maximum path sum. This is a very good problem, everyone. It is quite frequently asked in interviews as well. So, let's understand this problem. What is this? See, if you have solved or gone through the previous lectures which we have discussed in our sheet from binary trees, those might be easy questions, but we will be using that approach to solve better or medium to hard level questions. That is why easy level problems are very much required once you're starting with the topic. Okay, so you are given a binary tree in which each node element contains a number. Find the maximum possible path sum from one special node to another special node. Is a node connected to exactly one different node? That doesn't matter. What you need to understand here is that you have to find the maximum path sum between two special nodes. For example, if you see in this tree, your output is 16, right? That means the maximum sum lies between special node 4 and 5. 4 and 5. How is it? See, 4 plus 4 8 plus 3 11 plus 5 16. Let me take this example and show you. 3 4 5 minus 10 4. Okay, so for example, we have a tree like this: 3 4 5 minus 10 4. You basically have to find the maximum path sum in this tree. Now, what do you mean by maximum path sum? So see, what there might be multiple paths which you can take here to get the sum. If I start, for example, you are present here, you want to include 3. Let's go to the left of 3, you get 4. Let's keep calculating the sum. Okay, then let's go to minus 10. If you add minus 10, right, so your sum definitely is going to reduce because you are adding a negative value. We'll see what will be the sum. So right now your sum is minus 3. There is one path like this which is giving you a sum of minus 3. Let's take this path: 3 plus 4 plus 4. If I take this path, what will be my total sum? 11, right? 4 plus 4 8 plus 3 11. What if I take this path 3 to 5? It will be 8, right? And it's not mandatory that you have to always take a path like you are fixing a root node for yourself or node and then you are taking lefts and rights. It's not necessary. You just have to take a path traversing through any node of your tree. They should be connected. That's the only important part here. So I can take a path like this also: 10 minus 4 4 or minus 10 4 3 5. But if I take a path like this, 3 minus 10 4 3 5, you see that minus 10, a negative value, is anyway minimizing your sum, so it's better not to include a negative value. So what if I take a path like this from 4 4 3 5? Okay, and out of all the paths you will see that this path is giving you the maximum sum. Okay, and these are all connected nodes, right? 4 plus 4 plus 3 plus 5. Okay, that is giving you 16, which will be the maximum for this particular tree. Now, how are we going to solve this problem? So one thing you have understood for sure, that it is going to take you through the traversals of the nodes. Okay, but what kind of traversals? Are you going to traverse it in any particular way, and what will be your comparisons in order to get the maximum sum? So if you take, for example, if I just take one simple tree with only one left child and one right child. Okay, so what will you observe? For example, you are currently at this root, right? And let's say whenever we compare, let's start with the minimum value, max sum. Let's initialize it to minimum value minus infinity, for example. Although in integer this is not the minimum value, what we'll take is int dot min value, integer dot min value. Okay, for example, this is the case. Now my target is, which path can I take? So in order to take any path, I am currently at this node. I'll ask from my left subtree, give me your maximum path. Okay, so let's say your left will give you some left sum, right? Then I will ask the same thing. Okay, and which will be the maximum from the left side? Left side will give you its maximum sum path, which will be the sum. Okay, same thing, my right, I'll ask my right and it will give me the maximum sum that this right side can give me, they can provide me. Now my target is that I have my left sum, I have my right sum. Now what I want to check, there is a possibility that if I include left sum, right sum and myself, I might end up getting the maximum path sum. You getting my point? So now what we have to do here is that you have your left sum, you have your right sum, correct? Then you are checking if these are some non-null, obviously these are some values. You check one thing first. If let's say, let me write a pseudo code for you here so that you can understand. Let's say we start off with, you take some int left and make a call to the same function which I am at right now. Let's say that is your sum function, in which you pass root dot left, right? Then you do the same thing for right side and ask it to return you the maximum sum on the right side. Okay, root dot right. So now basically both the left and right sides will have their left sum and right sum. Now your target is, okay, that if your left, your roots dot left is also not null. See, base case conditions would be what? If this value is equal to null, for example, and this value is also equal to null, you have only one node. In that case, you will return root dot data. If, for example, one of the values is null, okay, either your left is null or your right is null, what are you going to return? If this is, so I'm just telling you the base case condition. After that, we'll go on what we have to do when we have a tree with both the root, both the child. Okay, so if you have a tree with only one of the nodes, in that case, you will return your own data plus whatever maximum whatever you got from the left side. And same thing, if you have only child at the right side, you will return your data and anything that you have on the right side. That is what, these are your base case conditions. One is when your root itself, root dot left is null, root dot right is null. In that case, only root's data is going to be returned. But okay, considering these are your base conditions, what are you going to do when you have both left child and right child? Okay, you know one thing for sure, that you are recursively calculating whatever sum you are going to get on your left and whatever sum you are going to get on your right. Now I have already taken some max sum. I will store my final value in my max sum, which will actually be math.max of. What will it compare? Now try to understand this thing. What is this going to compare? It is going to compare whatever max sum you already had, okay, whatever max sum you already had, and its comparison will be, what if you include whatever sum you got from your left side. See, whatever sum you got from your left side, left will return you 4 here, right will return you 5 here. Now, why not include myself in left and right and form a path? So it will be a path like this, right? So this is also one path. So I will see that what is the sum I'm getting by taking the left sum, right sum and including myself. So that will be left plus node dot value, whatever root is there, root dot value or data, plus myself, root dot data, plus what I got from the right end, right sum. Okay, now if this exceeds my max sum, which I have been calculating every time, if it is greater than that, then max sum will include the sum that I have gotten from this path. Now imagine this tree is the left subtree for some other node, let's say 7 here, let's assume. Now I know I have gotten a sum like this, okay, from the left hand side. What am I going to do now? See, anyway, you got this. Just for an example, if this was the case, you got your answer. But finally, what would you return actually? You will return again max of what? Your root dot data, whatever it is, plus left, if you include your left side, and you compare it with if you include yourself in the right side. Now, how is this going to work? I'll tell you. Plus your right end. See, how are we doing this thing? So, if we have an example like this, here in my max sum, max of root dot data plus left, root dot data plus right. Okay, this is what we are returning, and finally you want to return your max sum. That's what you are storing. Let me just take one. I'll tell you, we will take one more function let's say int whatever you want to return, max sum. Okay, so this is the function that you want to complete. Okay, it will have your root node. What we are actually doing is we are storing our answer. Let's say whatever I want to return, I am storing it in answer, which will be returned to me from your function that I have called here. Let's say this is your helper function, helper. So helper function will return me some value once I pass the root. Whatever that value is, I will see if my root dot left is not null and my root dot right is not null. I am going to store that answer, store in my sum will be math dot max of whatever sum you have and whatever answer you got from your helper function. Okay, so basically this is nothing, this is your max sum which I have taken there. So max sum is finally what you want to return. I'll tell you when we code, you'll understand it. Return max sum. So see, what are we doing here? Let's take this example. For example, what example we have? 3 4 minus 10. We'll do a dry run and you will understand this is 5. Okay, so see what is actually happening here. You take this. Okay, this is your function that you want to complete. You take a max answer. Okay, max answer, and then you make a call to your helper function. Now helper function's task is to find what maximum path you are getting, and we will compare it with your maximum and finally return your maximum. So you're passing your maximum. Right now maximum is minus infinity, let's say. Okay, right now your maximum is minus infinity and you are passing whatever answer you will get from this. Now see, int left, you are making a call to this sum or helper function, whatever I have written, root dot left. Okay, then further it will be a call will be made to root dot left. Now when I have root dot left is null and root dot right is also null, in that case you will return directly minus 10 here. Okay, now 4 has minus 10 from here, then you go to the right side, then you calculate its right, again backtracking, you will get 4 from here. Then when you commit this line of code, what are you checking? You are checking your max sum to be stored with math.max of whatever maximum. Right now it's minus infinity, and what if you include yourself in that answer? So since this is a negative value, obviously it will be greater than minus infinity, but okay, right now as of now I'm including it. Okay, 4 plus 4 8 minus 10 minus 2. This is what I'm going to get if I include it. Then what I have to actually return is your root dot data, what this call was made for which root. So I'm not going to get into much details of this, but all you need to understand, because this is backtracking, you need to have a good grip over recursion. You'll understand this thing when you do the dry run. Now what you have to actually find out here is that root dot data was this 4, right? 4 plus, if you include this left part, that will be obviously minus 6 negative, and if you include this right part, that is 8. What is the max of these two? It's definitely 8. Okay, and my max sum is stored with how much? Minus 10 plus 8 minus 2. So see, you're getting the point. Max sum is stored with minus 2 left, and we are actually returning max of these two things, right, which is 8. So finally I got this path as my maximum, returning me the maximum sum. So this returns 8 for itself. So you are understanding how we are handling these cases. This is the reason we are comparing here, that max sum should store if I include myself with my left side and my right side also. What is my sum? Okay, and then finally I'm returning whatever is the maximum of if I include my left side or if I include my right side, whichever is giving me the maximum value, I'll consider that and return my answer to the call that has called me. Okay, so now what? See, we are returning this. Now this returned value goes here, and it compares your max sum. Your max sum is stored with minus 2, right? Your max sum got updated, which is the maximum. See, so the task of this function is to compare whether I am getting the answer by including myself in both left and right part. See, it has gotten 3 options. One option is this one, other option is this one. So these 2 options are being compared and returned by this function in the last line. Okay, and the third option is if you include both left and right and yourself. So now 3 comparisons are done, 2 comparisons are done here, and it is returned. The maximum of these two is returned. And now it is further compared with what if I include myself also, but that value is -2, and answer I am getting from this function is definitely greater than that, which is by considering 4 plus 4 this path. So your max sum here will be 8, and as of now I have max sum as 8, but obviously this is not the end of the question because we have more notes to evaluate. I'm just telling you that how you are storing the answers if this was your entire tree, -10, 4, 4. Got it? So this has been handled. Now recursively when you go back, you'll check the same thing for 3 and same things will be done for every. So I hope this thing is clear to you now. If you guys have any doubts, you can ask me in the chat. Okay, so let's move to the code now, and meanwhile I'm coding. You can ask me any doubts that you guys have. Okay, so let's start off. So this is the function I want to complete, for which I will write another function. So let me take it as int. Let's say the final answer that I am trying to take in sum equal to math integer dot min value. Okay, fine. Now this is your function. Let's complete this. So int, let's take an answer, int answer equal to the function that you are going to make call to helper, let's say, and you are passing root, correct? Okay, now you will check if root dot left is not equal to null, or you can say is equal to null, or your root dot, if any one of them is equal to null, what are you going to do? In that case, sum is equal to math dot max of sum answer. Okay, fine. And then finally you return sum. Okay, cool. Now let's write our helper function. So int helper. Okay, so node that you are passing is your root node. Then you are checking your first base case condition. If root itself is a null value, what is the sum you'll return? Return 0, correct? If roots left is also null and your roots right is also null, we can take this after we make a call to int left. Left will be storing the left sum by making a call to your helper function by passing root dot left. Okay, then let's do the same thing for right by making call to helper function and passing root dot right. Now once the calls are made, I am going to check if my root dot right is equal to null and root dot left is also equal to null. If both left and right child is null, then you have no other option to return other than to return the data of the root node itself. So you return root dot, we have root right and data, root dot data. Okay, fine. If it's, let's say, left child is null, if root dot left is equal to null, return yourself root dot data plus root dot left plus whatever answer is there in your right side. Okay, similar thing you are going to do for your right part. If root dot right is null, then return root dot data plus whatever answer you have in your left. First we are gathering our answers from the left and right child. Okay, now what? Now you have to compare it. So whatever sum you had taken, sum should store math dot max of whatever sum you have as of now and whatever sum you will get if you include yourself in your left side and your right side. Left plus right plus root dot data plus right. Okay, so left plus root dot data plus right, that's what you are going to do and compare it with the sum. Whatever is the maximum will be stored here, and finally you will return the maximum that you will get either by considering the left side or by considering the right side. Math dot max of, if I include myself in the left part, or if I include root dot data plus left dot data plus left, and what answer I'll get if I include myself in the right side. Okay, so this I am returning, and this value will be returned finally to this sum, and that's what I am returning. Okay, I think if any one of them in your answer I'm storing helper. Okay, fine. So let us compile and check if are we getting the answer. Let's submit it. Okay, so that is all for this question. It is a question that needs you to understand the backtracking calls. It's something is not right. Let me take what went wrong here. So we are making a call to a root function. If root dot left is null or your root dot right is null. Okay, math dot max, whatever I have in my sum is integer dot and your answer, then I am returning sum, that is fine. Then I have the root node. If root is null, I return 0. Otherwise I'm making a call to left and right, root dot left, root dot right. If root dot right is equal to null and your root dot left is equal to null, I am going to return root dot is equal to null, return root dot data plus right, that is fine. If root dot right is null, return root dot data plus left. Then I am returning sum is equal to math dot max of sum comma left plus right plus root dot data, that is also okay. Now what is the issue? I don't see any issue here, although need to check why it's not working. Let us see. Must be some issue. Teacher, if you guys can figure out the issue, let me know. And sum is math dot max. We are making a call to sum helper. Okay, node root if root is null. Return root dot data done. So that is all for this question, guys. Okay, so the issue was the recursive call that I was making. So you were checking if your root dot right is null, then first you're calculating left side, right? That is the reason the swapping of these two lines led to some test cases failing. The reason is first you're calculating your left answer, so you won't have right answer here when you are going at this line, of course. So that was the issue. Okay, so let me know if you guys have any doubts. Okay, it's clear now there, Shankar. I hope you understood what was the issue. So if there are no doubts, we can wrap it up and see you all in the next lecture. Bye bye and take care.